Assalamu alaikum, dear students. Today topic is angle of friction and its relation with the coefficient of friction mu. First of all, we will try to define angle of friction. If you remember the previous class, suppose this is a table or a bench. If we kept here any load here, okay, here that means weight of the body is acting downwards. You know this weight, and this weight, this this is body one, this is body two. Body two presses in the upward direction, that means it is called a reaction force. You know this is called a normal reaction. I have already discussed with this. Normal reaction R, it is equal to weight of normal reaction is equal to mg. If we apply force here, applied force, this is called applied force. F is equal to applied force. Okay, applied force. When applied force, it develops a opposite force here. This is called force of friction in the opposite direction. The maximum value of the, when we go on applying a force here, it develops a force in the opposite direction. The force up to which this body does not move, it is static friction, or it's called a static force. The maximum value of static force friction is called the maximum value. That maximum value means जब इस वैल्यू को क्रॉस करेगी, जब अप्लाइड फोर्स, सपोज अगर अप्लाइड फोर्स 4 न्यूटन है, 4 न्यूटन तक ये बॉडी मूव नहीं होती है. अगर 4.1 न्यूटन में अप्लाई करूँगा, बॉडी स्टार्ट्स मूविंग. दैट मीन्स अप टू 4 न्यूटन द बॉडी does not move from its place. Up to this value, this is called, you know this is called limiting friction, or it is that is the maximum value of the static friction. The body is at rest, that is the body does not move on applying a force. This friction is called static friction, or its maximum value is called, maximum value of static friction is called limiting friction. We here say Fs max, that means maximum value of static friction. Maximum value of static friction is the limiting friction. Okay, if they are perpendiculars to each other here, if this is one vector, this is normal reaction, this is the another vector acting, this is a force acting in the another in this direction. The resultant of this series, if you look towards the normal reaction and maximum value of the static friction here, it is just like this. That means two vectors are joined by tail to tail. How can we find out their resultant? Their resultant is found by completing the parallelogram. If you remember the law of parallelogram of vectors, when we complete a parallelogram, and this is the vector, this diagonal, is joining here, is called the resultant. If you remember the vector classes here, if you I find out the resultant of these two forces here, normal reaction of this value of magnetism, this is called the resultant. Okay, resultant. What is this? It is the resultant of R means normal reaction. Normal reaction is denoted by R, and limiting friction. Limiting friction is the maximum value of static friction. You know this, I have discussed in previous class. Maximum value. Okay, this is the resultant R. Resultant of, this is called a resultant of, then resultant of Fs max and R. That means resultant of limiting friction and R, normal reaction. Here this angle, suppose this angle is theta. Now we have to define the angle of friction. Angle of friction, if we define the angle of friction, suppose it is denoted by theta. Angle of friction may be defined as the angle which the resultant of limiting friction and normal reaction. The resultant of this and this. What is the resultant of this and this? This is this line. Okay, suppose this resultant is, suppose I name it OC. OC is the resultant. Suppose this is OB here, OB. Suppose this is OA. The resultant of OB and OC. OB is the normal reaction, OA is the limiting friction. The resultant of this is OC. How we can find out the result? By parallelogram law of addition of vectors. The resultant of normal reaction and the limiting friction makes, that means resultant, this makes with the normal reaction, that means this angle. How can we define it? It is the, this is the angle between normal reaction and this. What is this line? It is the resultant of normal reaction and this limiting friction. This angle is called angle of friction. I hope you have got it. The angle of friction may be defined as the angle which the resultant or what is the resultant, this line, it is the resultant of limiting friction and normal resultant of limiting friction. Limiting friction is denoted by Fs max, that is the maximum value of static friction. You know this, we have discussed in previous classes. Resultant of limiting friction and normal reaction. This is the resultant of limiting friction and normal makes with normal reaction, normal reaction. How can we find out the resultant? By parallelogram law of addition of vectors. This is the parallelogram. We can complete the parallelogram. These two vectors are acting. They are joined by tail to tail. Here we can find out their resultant by making the parallelogram. The vector joining by the common tail. This is the diagonal joining by the common tail gives their resultant. This is the resultant. Okay, I hope you have. This is called angle of friction. Now we have to find out the relation between. I hope you have got it. Okay, the relation between I can write now theta is the angle of friction and coefficient of friction is mu. We can find out their relation. Now if you look towards the diagram here, in triangle this OBC, this is 90 degree here, this is 90 degree. Tan theta किसके बराबर? In triangle OBC. Okay, here OBC, this is 90 degree. This is angle theta here. This becomes the base. OB becomes base. This is perpendicular. Tan theta is equal to perpendicular divided by base. What is perpendicular? That is perpendicular is BC. If you look towards this diagram, BC is perpendicular divided by base. Base is OB. Okay, but BC is also equal to OA. BC is equal to OA. BC is equal to OA divided by OB. When we look towards the figure, this OA, it is the maximum value of static friction. Maximum value of static friction is the limiting friction. Okay, that means Fs max, that is maximum value of static friction. It is the limiting friction. Okay, yeah, you can write simply, or it is equal to Fl. It is limiting friction. Force, maximum value of static friction, it is called a limiting friction also. Force developed by this applied force, limiting Fl we can write, divided by OB. What is OB? OB is the normal reaction. Okay, you can write Fs max divided by R. Okay, that means tan theta you have got, it is equal to Fs max divided by R. Okay, this is equation first. If you remember the previous lecture, the relation between force and normal reaction. F is directly proportional to R. If you remember the previous lecture, F is force. That means force of friction. Here it is the maximum value of limiting friction. F max. That means maximum value of static. It is limiting friction. It is directly proportional to R, normal reaction. Or we can write Fs max is equal to mu is a coefficient of limiting friction, or the maximum value of this is here. It is called a static coefficient of static friction, or static friction or limiting friction में है the maximum value of static friction. If you remember the graph, also previous graph, the maximum value of static friction is called a limiting friction. Here we can get F as max divided by R is equal to mu s. Mu is the coefficient of static friction. This is equation second. Here we got another relation F as max. This is by laws of friction. हम already discuss किया ये. F as max is equal to mu s divided by R. F as max is equal to R divided by mu s. Comparing equation first with the equation second. When we compare equation first with equation second, this is tan theta is also equal to F as max divided by R. F as max divided by R is equal to mu s. When we compare these two equations, I can get tan theta is ultimately comparing equation first and second. When I compare equation first and second, we get tan theta is equal to mu s. This is the relation between theta and what is the relation? This is the relation between theta and coefficient of friction. That means the coefficient of static friction or the coefficient of static friction is equal to the tangent of the angle of friction. That means we can say the coefficient of static friction is equal to the tangent of angle of friction. I hope you have got it. Angle of friction. Here मैं थोड़ा बहुत आपको बताऊंगा. when we force apply कर लेंगे, ये नहीं हिलती है. जहाँ जब तक मैं फोर्स अप्लाई करूँगा, जब तक ये नहीं हिलेगी तब तक इसको कहते हैं, इस फोर्स को कहते हैं स्टैटिक फ्रिक्शन. और द मैक्सिमम वैल्यू ऑफ द स्टैटिक फ्रिक्शन, मैक्सिमम वैल्यू को जब आप इफ अप्लाई मोर फोर्स देन द बॉडी स्टार्ट्स मूविंग. अप टू दिस फोर्स अप्लाइड फोर्स द बॉडी डज नॉट मूव. इसको हम कहते हैं स्टैटिक फ्रिक्शन. और इस द मैक्सिमम वैल्यू ऑफ स्टैटिक फ्रिक्शन इज ऑल्सो लिमिटिंग फ्रिक्शन. We know that another two forces, weight is applying downwards and it gives reaction in the upward direction. This is called a normal reaction. When we these two vectors here, when we find out their resultant, how can we find out this? By parallelogram law of addition of factors, we can complete a parallelogram. That this is the diagonal, this is the result. That means this angle is called angle of friction. That means angle of friction किस के दरमियान है? It is the angle between this line and this line. This line is called normal reaction. This force is called, which is acting, this is called this line. It is the resultant of normal reaction and limiting friction or maximum value of static friction or limiting friction. ये इसका resultant. So the angle of friction may be defined as the angle which the resultant of limiting friction and normal reaction, the angle between the resultant of limiting and normal reaction mixed with the normal reaction. अगर हमें इसको साथ रिलेशन निकालें इन ट्रायंगल OBC tan theta is equal to perpendicular divided by base को, इसका BC divided by OB, but BC किसके बराबर है? OA. BC divided by OA is equal, this is equal to Fs max divided by R, or Fs max divided by R. But also we know that from laws of friction, Fs max is directly proportional to R. Fs max is equal to mu s divided by R. Alternation, this we can get is the coefficient of static friction. This tan theta is, that when coefficient of static friction is equal to tangent of the angle of friction. I hope you have got it. Inshallah we meet in the next class. Thank you very much.